others engaged in this very, very, very important topic that it's changing all our lives. And to see our students graduating with this kind of background is really important. And we wait a few minutes. I'll say something more about that once we get more people on board. But we're getting a nice audience here. John, do you think we should wait till Erdal comes back, or probably Erdal?
Um, yes, we can wait 1 minute more and then I start.
Yeah, because I think Erdal has to stay on there. People could be coming in late, on that other link.
Okay.
Yeah.
Okay, perfect. So, okay,
Let's,
I'm gonna start
here,
now.
let's wait. It's 4:03. Let's wait just 2 minutes to 4:05. And then I'll greet everybody and then turn it over to you, John,
Mhm.
to introduce Alonso. I just noticed we lost a couple people. Oh, okay. Okay, what do you think, John? Should we start? It's 4:05. Uh,
Yeah, start now. Just-
I hope more people join us, but I do want to thank you all that have joined us so far. And Alonso, just expect that others will probably be joining.
Yes.
There is a faculty meeting, well, faculty staff meeting with the union, uh,
Mhm.
collective bargaining unit discussion. But this is, part of our series, Pathways to Artificial Intelligence and Machine Learning, in which our students are presenting. And we're really very, very excited about the fact that we're able to have a team of data scientists that, of course, are special, that uh, create the artificial intelligence, machine learning algorithms, and
Mhm.
apply them, and are doing research in that area and creating new learning environments. And part of those new learning environments are what our students, like Alonzo Jones, who's going to speak today, are taking advantage of. I do want to turn this over to Dr. John Hyder Bautista, who is Alonso's mentor. This is the way we'll operate in this series. We hope to have a speaker every week on Mondays at this time, a student speaker, to be introduced by their mentor. We are giving a course on generative AI, uh, that is meeting now, and hopefully those students in the generative AI course. It's a course, generative AI, for building machine learning and deep learning models with applications. Okay. And we hope that those students eventually will be presenting also additional other students that our team are mentoring. So let me turn this over to Dr. Bautista to introduce our Alonso. Okay.
Hello, everyone. Welcome to this colloquium series of student leader discussion series that is being part of the computational data science program initiative, which started a couple of years ago, where we have undergrad students doing research with faculty at the CIS department. We have some students who have been very active in research, trying to learn different methodologies, ways for them to go into the AI, machine learning, deep learning field. So today we have Alonso Jones, who has been, um, I think, 2 terms in doing research with me. So he will presenting the learned image classification model for food recognition. He actually was working in creating some application that will be um, a predicting the probability of the or the food item to be recognized by this model. So he used a data set with around 2,000 images. So okay, I will give the time to Alonso Jones to present now. So welcome, Alonso, so you can present yourself and you can share the screen now.
Okay. Give me 1 second. All right. Hello, everybody. My name is Alonzo Jones. I am a senior in computer science, and I am presenting to you today my research in AI food recognition. And in this particular project, I was basically filling the role of a data scientist, and it was my idea to come up with something that would be used in the modern day. So I chose to lean more towards food recognition. And in doing so, we had decided to use three different models, which would have been the VGG19, the ResNet 50, and the MobileNet V2. And the VGG19 was a training model that is 19 layers deep in a neural network that can be loaded with pre trained models of the network trained one more than a million images in the data generator. It can classify images into different categories as well. And the ResNet 50 is a 50 layer sorry, conventional neural network. What residual networks are is a type of artificial neural network that forms networks by stacking the residual blocks. And then lastly we had the MobileNet V2, which is a conventional neural network that was 53 layers deep. All three of these models were used in tandem with one another to compare over the course of our research projects. And so, over the results of these, it came out to between the MobileNet V2, the fine tuned, and the ResNet 50. And so the V2 had the greatest accuracy between all three of these training models, and the one with the greatest size would have to become the ResNet 50, coming in at about 116 megabytes. The accuracy was as followed: the VGG19 was about 50%, the ResNet 50 was around 60 to 57%, and the fine tune came out to 66.1%. And the V2 came out to about 45 seconds to identify the images, but it came with a little bit more time for the accuracy since we had to pre-train the models up with thousands of images. And so this is why it was kind of rated the highest, because during the time that we had given to the other models, it came out to have the most amount of accuracy during these comparisons. And then so towards our conclusion, we experimented with about 4 to 5 different training models, and we learned that the model with the highest accuracy was not necessarily the most efficient in its production. We learned techniques such as quantization that will reduce the model size, and these techniques allowed us to reduce the model size and prediction time. But with limited reduction accuracy, we could also deploy larger models on a web server, but latency considerations may not make it ideal for all applications. So you might want to watch out for that. And from this, I came to conclude that with a little bit more training, the V2 fine tuned would have been the best model for this particular project in general. And so that's a little bit of overview of my project during the time with the professor and my mentor, Jan Bautista. And so I just wanted to show a little bit more of my poster that I had done during the time that I was doing this project.
Yeah, so you go a little bit up. Yeah, you can share again,
Oops,
Alonso.
sorry.
Uh, and then for people to see the title, I think it was a little high. High, you go up. Okay, that's the title now. Okay, you have any questions regarding the presentation? Do you finish, Alonso?
Yes, I pretty much finished majority of the overview
Okay,
towards.
okay. Now we can go to questions for the audience. You can keep sharing, Alonso.
Oops.
Yeah,
It's just I can't see when I share my screen.
yeah, you can keep sharing. Okay, it's
You-
good.
I see people just joining us now from the other website. Alonzo, I think we probably need to, and John, probably we need to say more about uh,
Oh,
what's the motivation here, and,
okay.
what are our objectives and goal before we actually get into the
Okay.
the discussion that's on the slide.
Okay. Yeah. Okay. So yeah, the motivation, as Alonso mentioned, he wants to work in this project. So initially we start doing the research. I present to the group variety of projects they can choose from. And he chooses this one. He feels more identified to this kind of project. He wants to work with neural networks. And he was testing three basic neural networks that that it was working perfectly with the data, and he was training the model with deep learning approach, and then gets on accuracy as a parameter for the results. So he was concluding that the accuracy was not enough or not a sufficient metric in the production stage of in the industry or market stage. So he realized that he need to look at in other metrics besides accuracy. So I asked him, okay, you have to go now to other classification metrics, and that will come out after the next term. We start looking. He wants to continue the project, but I think he choose another one, right? And he moved to another project. But initially, that was a beautiful thing to show. Like he realized the accuracy was not the only metric he can rely for this kind of classification project. Um, but also, eh, Alonso was trying to use this model in uh, for mobile apps, or trying to extend it to other um, capabilities, not just the website. But we didn't wait that further because maybe we will need more resources, and we didn't have at that time. But yeah, so here you notice this is a poster presentation that he was going to Tampa to present in a conference. Um, so the significance of the research it is it goes beyond the technical exploration. It actually go across many domains today when we talk about AI tools, because it can be applied for other kind of image recognition, not only food, but uh, it could go through biology, chemistry, any field that they need a computer to recognize uh, patterns from behaviors in specific data. So yeah, I don't know if the audience have questions for John's for me regarding the.
Yeah. So, yeah, John, I have a question I bring up. This is very, very interesting, being able to recognize food. And one of the things I'm very interested in, I think might be of interest to people in the healthcare and healthcare management, if this particular application is recognizing food. Can it, you know, food that needs refrigeration, for example, uh, and is not refrigerated will spoil. Uh, can this algorithm be used to recognize whether uh, s- some food is spoiled, that it's palatable to eat? I think this could be a beautiful application in our kitchens, whether they be in hospitals or restaurants, what have you. Are we going in that direction?
Well, so what you were trying to do, Jones, in the beginning, Alonso, you want to?
Yeah, so the reason I chose this one is because, as the professor was saying, I chose this more in a culinary context, and because in I was also using this for healthcare as well because my family all works in healthcare, and I was seeing how I was looking at more diseases that come with cognitive abilities that you're not able to recognize certain objects and things, and so that's why I chose more towards this one because this could be used in the healthcare field as well to help people who can't identify certain things or certain foods, and then this could be used in other applications as well, like you said in the healthcare field that, oh, is it palatable, oh, is it spoiled, and I feel as though given time, this could be branched out into something that can be used almost generally in day-to-day use. And so that's why I chose more towards this project than the seven other projects that I was given a selection for.
Well, I think that's excellent because, this is what we want to do, especially our motivation with our AI machine learning program
Mhm.
uh, is um, is definitely about AI's impact on society, and there could be very good impacts and there could be bad impacts, and we want to know what those are. And here is a beautiful example, I think, here where we could use this in the palatability of food, whether it be in our restaurants or in our hospitals, what have you. So, how much has to be done to refine? What would be your next steps in this application?
Um, So my next steps in this application would, number one, expanding the amount of images that it can be recognized. Because I believe for this one we only trained about 3,000 images per like different sets, and so from there I would increase the amount of images that it can use, and then from there I would show it images of spoiled items and images of palatable items, and then from there train it on to see, okay, is it able to recognize if food is spoiled? Is it able to be recognized if food was just freshly made or has it been out for a couple of days? And that would be sort of my kind of next steps of just like a straight out plan of what I would do to, further this kind of training model.
And how long do you think it would take to do something like that?
Seeing how this only took about a month or two for the projects, feeding it a little bit more images and a little bit more refinement, I feel like it could take about just about the same amount of time, about 2 months, 3 months, and then we'd be able to refine this a lot more than the base model that we have right now.
Yeah, like I said, this is very interesting. I have not seen anything done in this direction. I don't know about our audience here if members of the people here have seen anything in this direction. We would like to open it for discussion, people from the audience.
You can
And
post your question also in the chat. You don't want to. Uh,
oh, did you, John? You said there were questions in the chat.
no, I say the audience can
Oh,
post
sure.
anything on the chat.
Yeah, please, please. Uh, uh, what do you think about publishing this article, this work?
Um, I feel I would just need a little bit more polishing up on it. I feel as though I can create a little bit more, add a little bit more details because I feel like the poster I have of right now is a little bit too baseline. But given about a week or two of a little bit more polishing, I feel as though I would love to publish this. I would love to work furthermore into this project that I have going on right now.
Yeah, something we can with I say a challenge was the computational resources, because we wanted to continue when he had to switch to a different project, right? But the challenge was that we didn't have any computational resources, because this consume a lot of computation to run the models. I think now that we have uh, Nautilus cluster, maybe we can try that one. That's another challenge. So,
I see John, Dean Mary Simmons has her hand up.
oh yeah, Mary Simmons. Hi, you have a question?
Yes, hi. Thank you, Dr. Ello, for the invitation. I think this is a good project also, and well worth the time to put more study into it. I do want to add on to what Dr. Ello stated about using this type of project to detect if foods are spoiled or if how long have they been out of their shelf life, as that pertains to health. And I'm sorry, I'm Mary Simmons. I serve as the dean in the School of Allied Health Sciences. And so it's very intriguing because if we can detect, I'm envisioning you're in the grocery store,
Mm-hmm.
right? And there's an app to determine, how long or if the food is spoiled, how long it is it over its shelf life or whatever that is, because dates are just dates, right? But it doesn't
Mm-hmm.
mean that that's an accurate date. So I'm thinking about that. And now, Jones, I'm pushing you out into the health field now, saying, hey, what about an app like we have the heart apps and those type apps,
Mm-hmm.
being able to detect something more bigger using
Yes.
AI as it relates. So I commend you on this, and hopefully I get to see other projects come out of this and move forward with even into the health arena of using AI recognition.
Yeah, Dean Simmons, I really appreciate you bringing that up. I have this is great because going back to say in the supermarket, yeah, where you have meats being ground or processed. I'm talking on the fresh food side or fruits and all that kind of stuff on the, that are being cut up and put into packages. This would be very helpful. There is an app. I don't know how many of you are aware of it, YUKA, that will look at barcodes on cans and tell you on cans and processed food and tell you about the what's being processed, what is in that processing, and it gives a rating, whether or not it's very poor or excellent, from 0 to 100. But that's on barcodes that are on processed food. Here, I think Dean Simmons and I are, pushing the idea of all this fresh meats and things that are cut up in the supermarket. This app, that kind of app, would be extremely helpful. This food recognition. Uh, what's your all's thoughts, Dr. Prada, Alonso?
Yes, yeah, as Dr. Maris Simon mentioned, there are different culinary contests. If you can imagine different possibilities of how you can use this AI food recognition. So, and yeah, so being like right now in the market, some apps like this, when people want to track, calories of carbohydrates of different types of diets. Uh, but Alan Jones, and we can discuss, a different approach, something innovative, something we don't see. We
Mm-hmm.
can work on that. Because as I say, this is for different culinary contexts. In this case,
Mm-hmm.
we can still use the same data to train and the preliminary model. Um, because we have the data already trained. Um, And then we can add other different kind of data that maybe is gonna fit that purpose for. So we actually had to discuss more with Alonso what other culinary contexts we can apply. But this is a very good idea. I just realized now how important can be. Yeah.
Oh yeah,
Yes.
Yeah.
I definitely. Uh, uh, you know, let's see, challenging minds. That's the whole thing. Creating lives, challenging minds, and creating lives. So, Alonso, I hope. Do you go by Alonso or Mark?
Either or is fine. Some of my friends call me Alonzo. In
Oh,
more like professional setting, people call me
I
Marcus.
hope you pick up on this quickly. The
Yes.
reason why I say that is because over my whole professional career, I've always been amazed how ideas come up and then the ether picks it up and other people grab onto it. And I don't know, there's something about that. But it would just be great to move on this quickly, and I would
Yes.
publish it with the ideas that we're talking about. Even if you publish it with what you already know,
Hmm.
a section that says, here's our future. And
Dr. Alo? Uh,
yes,
yeah, no, sorry. I'm gonna put you as a co-host as I have another meeting in 1 minute. Uh,
oh,
and this is
okay,
for one of the clubs. So let me
okay,
make you a co-host.
okay.
And now I can leave the meeting. You can continue. So Alonso, see you next time.
See you next time,
Thank you.
Professor.
Okay.
Thank you, Dr. Prada.
All right. Thank you so much, Jose.
Thank you. Okay, so I just want to encourage that
Hmm.
because I, ideas like this are, what we need to get out there right away. Someone else may have thought of this, who knows, but you will find out, once you send it off, the ideas to be published, but you have to indicate, you know, uh, what's your next steps. Okay.
Yes.
You do want to enhance this, uh,
Hmm.
what you have already, and I think Dr. Bautista and other members of the AI, data science, AI, machine learning cluster can help you on it. And and I hope Dean Mary Simmons can give you some advice on it also.
Yes.
Uh, I think I think she's still with us. Mary, are you still with
Yes.
us?
Yes, I'm still here.
Yeah. What do you think about this, getting out there and getting at least putting a preliminary publication out there?
Oh yeah, sure. I think this is worth publishing. You almost want to try to patent something before so no one takes your idea, you know?
Yes.
Exactly. And that's enough. Thank you for suggesting that because okay, Alonso, get Dr. Parabautista to introduce you to our uh, technology transfer director, uh,
Okay.
David Teak. Okay.
Okay.
And I also will talk to him, but yeah, you do need to start thinking about how will we put this together. Okay.
Okay. Yes, sir.
Other questions from anyone? This was very exciting. I'm very glad to see this. Any?
Yeah, I have a question here and a few remarks. Of course, this is Nelly Mateva. I'm a chemistry professor. So, first of all, the presentation was excellent. Thank you very much. This was a great work. So, as a chemist, I'm really concerned about recognizing foods that contain, for example, harmful, obviously proven harmful substances such as azo-dyes, certain sweeteners, and so on. This is very important for everybody's diet, not only people with certain conditions. So, do you think that you can include something like this in your model?
I feel like we can, as long as there's like a certain kind of, I don't want to say example, but since this is based off of image recognition, as long as there are certain images that can show the kind of symptoms that,
Mm-hmm.
like you were saying, if there's some dangerous chemicals within the food, as long as there's images to provide the model, then we will be easily be able to implement that within the training models.
Okay, well, let's think about this.
Mm-hmm.
Let's think about this. Yeah, this will be actually something excellent to show to everybody. Yeah, and of course to publish or patent. Yeah.
Yes, ma'am.
Okay. Thank you, Alonso.
So do we have other input from others here? Anyone else? So, Alonso, you're graduating this semester, is that correct?
Next semester.
Uh-huh. And what are your plans?
Right now I'm looking towards a full-time position with Capital One as a software engineer, and as of right now, I'm waiting on the application. I was in talks with the HR team, Tiffany Brown, and so that's kind of my plans moving forward to see if I can get a full-time position with Capital One or any kind of startup company, or yeah, that's kind of my plan as of right now. I'm not too worried. I was worrying during the summer, but then my dad came to me. He's like, "You should relax and slow down. You have plenty of opportunities ahead of you." So I think I want to start moving towards that direction.
Well, do not let up. Do not let up on your work in advancing in artificial intelligence and machine learning.
Yes, sir.
This is university education is rapidly changing,
Hmm.
and these tools, data science, artificial intelligence, which fosters, of course, artificial intelligence, machine learning, deep learning, are in demand for all our graduates. Doesn't matter if you're in STEM or non-STEM. All our graduates are going to be entering the digital professions.
Hmm.
All our professions are digitalized. And to be successful, you not only need your degree, whether it's in computer science or it's in humanities or in allied health, you're going to also need these and how to use these tools. So don't give up on this. Keep going. You've started a good foundation here. And
Yes, sir.
it will behoove you to move in this direction, whether you go to Capital One or you go whatever job you go to advance. And so hopefully we will have our master's program coming up soon in data science, artificial intelligence.
Yes, sir.
And you might consider that. I hope we will have it as an online program. And so definitely consider that.
I will.
Hey, other questions from anybody? Are we all okay?
I have a question.
Go ahead.
Hello, everyone. Hello, Alonzo, Dr. Reeves, School of Allied Health Sciences, Division of Physical Therapy. And I joined a little late. I just entered the meeting. Could you just explain? This is so intriguing. Could you explain a little bit about the depth of the neural network? I see where you talk about, you mentioned 53 layers deep and 19 layers deep. Could you explain that a little bit for someone
Yeah.
that's
So
a novice, doesn't know?
when I first started doing the project, this was kind of like my introduction to these training models. And so basically, depending on how many layers the neural network has, is don't want to say how much more computational power it would take to, further enhance its training capabilities, but I would kind of like put it in the base terms as the more neural networks it has, the quicker and more efficient it's able to think.
Okay, thank you.
No problem.
Um, to give you a little bit more about the number of layers that the neural network has,
Yes.
it's a measure of how complex the neural network is, because what happens is that each layer is connected to each layer, and so therefore the more layers you have, the more layers of computation that you go through. What we've kind of seen is that after you get past a certain number of layers, what happens is that, especially for reasoning models, the layers go through a certain kind of reasoning process where they kind of eliminate things that have a low probability of being true while trying to push forward things that have a higher probability of being true. and so it's a measure of complexity. Sometimes these bigger networks have billions of neurons, and those are thousands and thousands of actual layers that they put together. And right now there is a struggle between either making them larger or making them actually smaller, more compact to focus on doing specific things well. But that's basically what your neural networks your layers are.
Thank you, Dr. Maurice. Thank you.
Okay. Thank you, Dr. Maurice. That was very good.
Mm-hmm.
Other people? Well, if there are no more questions, I do want to thank everyone for joining that has joined us. We're going to continue this series. We're trying to have these every Monday at this time. And these are our students, and they can be in any discipline. So if any of our faculty that are on here are from out any discipline whatsoever, having students using these tools, please let us know, and we'd love to have them give a presentation. It's important, the dedication of our students as they're learning these tools. And as I said, we hope that this will lay the groundwork for our expected master's program. Thank you, everybody. And are there any other questions before we sign off?
Oh, I was just going to add one other thing. If you have students who are interested in learning these tools and how to use them, we can help with that as well.
Yes, that's correct. Oh, do you want to tell people about the workshops that are coming up, Erdell?
Um, I didn't set the first date to start. I was hoping to start it next week. But we are redoing the workshops for faculty and staff. And those workshops are an introduction to artificial intelligence. Like the question that they were asked earlier, what's a neural network and what's the different layers? We started that, and then we go all the way up to teaching you how to use AI to help you code to actually create projects just like the one that you saw today. With the conjunction of using AI to build AI, it's actually not that difficult to start from scratch and get to a place where you can create something that's useful. Um, um,
And we're going to start with we're going to talk about generative AI.
yes, a good example of that was that my son is learning, he's in 10th, he's in the fourth grade, and he's learning words. And so I just asked Google Gemini to write code for what's it called, a spelling app. And so all I do is I give it the text. I said I was going to give you the text of all the words that he was learning to spell. And then it created an app that would speak the word out, have him type it in and check the answer if it's right or not.
That's an excellent example. And I want to and just emphasize, so as Erdal has said, we're going to run these workshops like we did last semester, but we're enhancing the workshops. We're running faculty, staff, and students. And the idea is, with generative AI, it's, programming. If you're concerned about being able to write programs, you don't need to really worry about that much anymore, because as he just mentioned, you know, uh, we have our tools that will help us do that. Okay. So the real uh, issues out there to learn how generative AI works. And that's what we're doing in the course we're teaching. We're teaching a special topics course right now. It's called Generative Introduction to Generative AI for building machine and learning and deep learning models with societal applications. And so we hope that this special topics course will lay the foundation for a regular course at the undergraduate level. Right now we have upper level undergraduates and some graduate students in that 4,000 level course. But this is a very, very important topic. And this is what we definitely would like to see our students graduate with, this kind of background. It's in demand in the workforce. And so we also hope to have our members of our data science, artificial intelligence, machine learning cluster work hand in hand with any faculty member that needs help in getting directly connected to the computing resources which are on the National Research Platform, of which our institution is connected to. So anyone that needs help, just let us know, and members of our team will give you a hand. Okay. Any questions on any of that? And I think, are those starting on September 17th, Erdell?
Yes.
Okay. So a flyer will be coming out for September 17th at 4 o'clock. Is that right? 4 p.m.?
Yes. Yes,
Okay.
4 o'clock. Mhm.
Well, thank you, everybody. I don't see anything else in the chats. We appreciate your attending. We hope to see you again and more and others next week. Okay.
Thank you.
Thank you.
Thank you,
Good luck,
everybody.
Alonzo.
Thank you, everybody. Bye.
Thank you, Alonzo.
No problem. See you
Bye.
guys.
Great job.
Thank you.
To get myself out. There we go.